What my thing? Yes. Okay, so I did how numbers affects how we think, because numbers are everywhere in everyday life. You know, like the days on the calendar, the time of day, how much you weigh, how far away something is from something else. Okay. So yeah, numbers are every day. We think about them every day to the point like it's just become second nature. We see numbers all the time, and we know what we're doing with numbers every day. So how do they affect how we think? That's the question that I had on the board. So, calculation difficulties. Say you have two deals presented to you in like Walmart or something. So one of them is 41 cents an item, and the other one is 27.47 for 67 items. Now this one sounds great, like gross, 67 things for like nearly 30 bucks. But if you were to do the actual math, you would realize that both this one and the former are the same unit price. But why does this one sound more appealing? It's because this one just sounds like you're getting more of a deal, because it sounds more dramatic. There's more going on here than there is in the simple 41 cents. Here it sounds bigger, and that's how numbers can be manipulated and twisted to make us sound more appealing or less appealing, depending on how we're going to buy it in order. Now, let's say you're doing math casually, and you get a factorial, like 5. Now, factorials have been brought up already, but in case you forgot, this exclamation point just means that you multiply all the consecutive numbers before said number. So 5 factorial in this case would be 5 times 4 times 3 times 2 times 1, or the reverse, or any rearrangement of those numbers, but traditionally it would be 5 that everything before. But if you were to see 5 times 4 times 3 times 2 times 1, and then this one, you would think that this one is just generically like greater than this one. But why? Why do you think that? That's because you see 5 times 4 first, and you are thereby set up to see bigger numbers first. And when you see the bigger numbers first, you automatically think bigger than if you receive 1 times 2, because 5 times 4 is 20, and 20 is like 10 times more than 2. So you just think bigger numbers are bigger because they are bigger. Why do you do that? Why do you do that? That's priming. What is priming? I'll get into priming. That's my next slide. Look at that flow. Look at that. Priming. Okay. Now priming is a little hard to explain. Priming is like the reflexes of your brain. Because if you don't know, reflexes are in your spinal cord, and they think for you. If you touch a hot stove and you pull away really quickly, that's your spine working out of your brain. But priming is if your brain was working. So if you see something, if I were to tell you yellow, if you saw yellow, you would automatically be able to recognize more traditionally yellow things like a banana or like a taxi, or I don't know, an apple, yellow apple, but apples are red. Forget apple. Apples are better. Okay. I can tell you that priming is a non-conscious form of human memory concerned with perceptual identification of words, but that's hard. That's just complicated. But like, okay. So what's priming? Okay, so if I were to tell you, I really enjoy showering. I love showering. Showering is great. Like, it makes me feel so clean in the morning or at night. Just like get all that off me. And Mr. Clean, bro. Look at this man. Look at Mr. Clean. Like, this man's great. He's like makes really good dishes. And you know the water is always so good. It just works really well. Now, why did I tell you all that about still? I want you to fill in this word for me. Fill in this word for me. What did y'all think of? Did y'all think of soap? Did y'all think of soap? Yeah. That's priming right there. See, that worked. It's cool. That works. That's priming. So I got y'all thinking about things related to soap without actually even saying soap. I just got y'all thinking. I got you primed, even. So okay, but enough about psychology. This is a math presentation. Units. This is where things get wild. All right. So units. Pretty much whenever you see a number, like in day-to-day life, there's probably a unit attached to it. Like, you know, how tall you are, you're 6 feet tall. If how far away you're going, that's like 2 miles. How much you weigh, 150 pounds. You know, there's always a unit usually attached to numbers. Usually there are no naked numbers in day-to-day life, so. Oh, that was disgusting. Units can be twisted very easily. Like before I said about like, you know, like the 2 deals with like the 41 cents and the $30, that was me twisting the units around and adding more than necessary. So if you were a bad person and I got a 30-day service penalty, 30 days sounds a lot bigger than 1 month because there's 30 days, but there's 1 month. So, and if you were to take out a loan for I don't know, like a car or something, or a house, if you're rich enough to afford a house over 15 years, that's a pretty, usually it's 30 loan mortgages. But a loan over 180 months sounds more reasonable and approachable than 15 years because there is more time, more payments to pay off the loan. But let's get into that a little more because honestly, loans are hard. And y'all children in here who have never paid a loan before, you're lucky. Okay, so this is not exactly practical, but it works. So let's say you take out a 25K loan that you plan to pay off the next 15 years with 9% interest. This probably is not a loan that exists, which I guess makes it easier in the terms of hypothetical stuff. Would it be more beneficial to pay the 9% annually over 15 years, or to divide it up between the 180 months that you have been presented with yourself? So if you were to just like run it really quickly in your head, you would see that if you were to divide the 25K over the 15 years objectively without interest, you would pay $1,666.66 every year. That's just without interest, and like if you can pull up with $1,600. But if you were to divide it up over the 180 months that you get in the 15 years, you would realize that is a much more manageable, nearly $140. That sounds a lot more approachable than if you just pulled out nearly 2K. It's a lot easier to do 140 than it is 1,600. How is interest calculated? So we're gonna get it. This is interest. It's just a little more complicated, I seem. So future value. The concept of future value is basically interest, and you get this equation here. This equation. So FV is future value and equals all this. What is all this? So you get the real value. I'm gonna explain this really simply because this is really makes sense. You have the future value times 1 and the interest rate times however long, to the power of however long you will have that interest rate. So if you were to say have the 25K with the 9%, it would be the 25K times the 1 plus the 0.9% to the power of however long you would be paying it, which in this case would be 15 years. And this is the continuous interest formula, which isn't very practical, but it is fun. You find math fun. But this is just if instead of there were intervals of time where you pay off the loan, it just keeps rising like forever until you hit the point where you have to pay it back. So what does this mean? So our loan problem. If you were what math I've done is the problem I presented with you. Is it better to take a loan out in years or in months? And if you look at this is the yearly interest, which is 91K, which I mean, but I mean, the monthlies over the 180 is nearly 4K more. That's insane because objectively it shouldn't matter because if it's just the same amount of time, why does it matter? It's just the same. I said the same thing like 4 times, but And I did daily interest just for fun, and this also turns out to be like 1K more than this and like 5K more than this. So that in terms of, and the continuous interest formula, which isn't practical but it is good for examples, is like $20 more than this. But like this just shows that I got y'all. That I presented y'all with the monthly loan being better, when in fact I just ended up making 4 more K for myself. So what does this mean? It means that we think wrong. This shows that even when we think it would be safer, that I was able to twist it, and I was able to make it better for me, make me sound better, when in fact I just pretty much scammed y'all. So yeah, so it just shows that we need to think a little more about the numbers. That just because it sounds good doesn't mean it is good. Then we have to at least consider things before we consider things. So what's next is just just think before you think. That's what I'm trying to say. And you can end up like this man here with the big brain. Y'all want to be like this, all right?